All right. So, guys, I've already apologized for my voice. I'm not keeping well. Hence, you hear my voice coming out all, very wild. So, yeah, I am Mekhla, and, I work as a community manager for Crystal at Manas. I have recently joined the organization and, trying to learn the language myself. The reason, I wanted to collaborate with this group or, certainly with other groups as well, because, Crystal shares syntax, with Ruby. So that is the reason I thought, that was my thought process actually to, get in touch with all the Ruby groups for that matter. But again, to understand the language, which is actually Crystal, and this is something which is actually born and raised at the organization that I work for. It actually it has a great community. It has, passionate individuals who are actually who is actually contributing to this project. And I wanted to introduce that to everybody who's using Ruby. That will be again your choice to continue using Ruby. But again, I think all developers are very keen on learning new languages here and there. So that is the reason that was my thought process to collaborate here. And I think, we already have Beta, who's actually the product manager for Crystal at Manas. There he is. Hi, Beta. So he will actually give us an overview of the product overall and how do you actually get started, with Crystal. So over to you, Beta. Thank you.
Hello, can you hear me?
Yes.
Great. So let me present my screen. Here it is. Can you see the screen now?
We can. Yeah.
If I move the pointer, you can see it?
Yeah.
Everything's set up. All right. So yes, I'm Beta Ziliani from Manas Tech. I'm leading the development of the Crystal programming language, a language that we say is for humans and computers. And part of the talk, I'm going to say why we consider Crystal a language for humans and why we consider Crystal a language for computers. Since I'm talking to a Rubyist audience, I thought it was a good idea to compare Crystal and Ruby. You will see that there are a lot of similarities among these two languages. And then the question arises that when you will want to use one or when you want to use the other. By the end, I'm going to present more features to get you excited about Crystal. At any part of this talk, if you have a question, please raise your hand. I know my accent might not be easy for everybody to follow. English is a hard language. It's the second language, probably. I don't know for you folks, but for me, it is. So if you have a question, let me know. All right. Let's start with Crystal is a language for humans. Why? Well, because humans, we like to write and read clean code. This is certainly true for Rubyist. Ruby makes the point of making the language very clean. And the code that you can see here, you can notice already, if you have a Ruby background, that it looks very familiar to Ruby. So familiar that if I don't tell you that this is Crystal, you might think this is actually Ruby code. But no, this is Crystal. This is 100% Crystal code. You can take this code, run it on Crystal, and you see what's happening. So let's talk about what the code here does. It's a simple HTTP server that starts on a certain port, 8080. And when you write localhost colon 8080/something, it will reply with hello world got something. Simple echo server, right? As I mentioned, there is a lot of similarities to Ruby that you can see. Like for instance, we have object orientation like Ruby with class. The require also looks familiar to Ruby developers. Maybe more important, we have blocks of code with this do end. As in Ruby, if you're a Rubyist, you know that this code is going to run in the context of the server new function, and so on. But so the point here is Crystal is very clean to look. You can read the code and see what's going on very easily. Also, another characteristic of humans is that we want to jump into a project and start getting something. We don't want to spend a lot of time until we have some result. So Crystal avoids dependencies by having a very rich standard library. Again, if you know Ruby, Ruby has something very similar, also has a very rich standard library, and we have that too in Crystal. It's battery included, as we call it. So for instance, the server here and the logging that I'm making here, these are all part of the standard library. So you can actually run this code and get it running on your computer without any further dependency. So also humans want their program to not fail. And consider this code that, again, it might be confused by Ruby code because it works in Ruby and in Crystal as well, although with a key difference. Here we have a class duck that quacks. And so we have the duck, when you call the method quack, prints the duck quacks. Puts is like printing in other languages. Then we flip a coin, and in one case, we create a new duck, and then we call quack. Now, what happens when the coin falls the other way around? Well, the duck will be nil, right? If you call this code in Ruby, half of the time it will work, and the duck will quack. But half of the time, the duck will not be there. There will be a nil, and you get a nil pointer exception. Well, I'm confusing here, but in Ruby, this is called another way, but in other languages, it is called null pointer exception, right? In Crystal, instead, we have a type checker that will check this code and said, no, sorry. In line 11 here, we have a duck or a nil object. And quack is not defined for nil, so you cannot call it quack. You can only call methods that are defined in duck and in nil. So, okay, this is nice. Crystal warns us before even executing the code that there's something wrong in our code. We have a bug here to fix. Now, as humans, we also want to fix things quickly to test something maybe. So we can avoid bureaucracy and simply add the nil struct, in this case, this is a technicality, a method to quack. But in this case, instead of making quack, nil will make right? So now both nil and duck quacks. So we can now run this example on Crystal, and Crystal will be happy to run this. And sometimes it will quack, and sometimes it will shh. If you know what this is called duck typing. If it quacks, it quacks. That's where it gets the name from. And also we have the monkey patching, like in Ruby. In Ruby, you can also do this idea of you have a type, you extend the type with new functionality on your code. In this case, we make nil now to be capable of quacking. And we have that too in Crystal. Okay. So let me make a little pause here and ask, are there any questions so far? I'm going too fast. Is this okay? Or we good?
Yeah, we are good.
All right. So summing up, we said Crystal is a language for humans because it's pretty like Ruby. If you're a Rubyist, I mean, I'm certain that you will agree with me. It has similar syntaxes, but compatibility is not a goal. Let me say that. We just happen to love Ruby, and this is why our syntax is very close to it. But it's safer than Ruby because it checks types and has type inference that allows you to avoid needing to write boilerplate types. Like I didn't mention this enough, but in the first example here, you don't see any type annotation here. And this is because we don't need it. The type inference mechanism of Crystal will infer all the types. Plus, backtyping and monkey punching, this allows you to have a language with free of bureaucracy. All right. Why Crystal is for computers? Well, because computers like native code, and Crystal compiles to native code, and that allows you to have performant execution. I'm showing here just two random benchmarks that I found on the internet. These are not precise and not meant to be taken super serious. But when you look at all the benchmarks available and even the experience as a developer working with Ruby and with Crystal, you notice that, of course, Crystal is much more efficient than Ruby because Ruby is an interpreted language. And there's this big distinction between interpreted languages and compiled languages. And this is what you see here. Crystal fares very similar to other compiled languages like Java, C++, and C. Java is compiled to a virtual machine code, but anyway, let's call it a compile. If I put Python here, it will be also in the same ballpark as Ruby because it's an interpreted language, right? So that's the big division here. What is interesting of Crystal is that it still feels very much like working with Ruby, although it is compiled and is efficient, right? And not only in terms of execution speed, but also in terms of memory footprint. It uses memory also in the order of magnitude of efficient languages like C or C++. Depending on the case, not every case is going to be the same. Crystal, I didn't mention this, is a garbage collected language, so you don't have to take care of freeing the memory. This is like Ruby. And you see here, talking about benchmarks, just let me make a digression here. You can see Java takes a lot more of memory here. And there's a correlation. We saw in the previous slide that also Java was the fastest one. So Java is kind of cheating. It's not collecting the memory. It's just putting everything there in the heap and never collecting it. So then it's fast. So this is what I'm saying here with distrust benchmarks. You need to know first the code in detail to know what the code is doing, then when the garbage collection is being called and the parameters for the garbage collection and so on and so forth. The high level point that I want to make here is Crystal is efficient as a compiled language because it is a compiled language. Computers like operating systems and Crystal loves them too. We have support on most of the operating systems out there, all Linux flavors and Unix flavors, and Windows with a caveat. So summing up, we say the language is Crystal is a language for computers because it competes with performant compiled languages in terms of speed and memory consumption, and is supported by several operating systems. Hold on a second. I need to take care of something. I will be back in a second. Oh, sorry. Sorry about that. So I was saying, so it's supported in several OSs. In Windows, we hope to have full support by the following release. Crystal is released 4 times a year. And hopefully the next release will be having full support for Crystal for Windows. It's almost there. All right. So I show you through several examples that Crystal looks very much like Ruby, but what it means to you, why would you change Ruby for Crystal, right? I mean, Crystal is better than Ruby in that it executes faster, has smaller memory consumption, and that makes a greener language, because if you consume fewer resources, you have a server that is more relaxed, more happy, consumes fewer electricity. It's also cheaper because you need fewer servers, or a server that is not as big. It's easier to deploy because you don't need the interpreter. You just need the binaries. You send the binaries out there, and people can start running your program. Also, you can do static linking, but this is another story. And it's safer. But well, let's be honest here. Ruby is better than Crystal in other aspects. Like with Ruby as an interpreted language, you can do much faster development because you change something in your code, you save, and you immediately see reflected that in your program. You don't need to wait for the compiler. Also, Ruby is a much more mature language. It has a larger ecosystem, a larger community. That means more library available, more people to help you out. So what's the story here? They're incomparable. You cannot say one is better than the other, right? They simply serve different purposes. And you have to use what works best for you. And it might not even be Crystal, or might not even be Ruby. And there are a zillion languages out there. We love it, of course, we love it. We love it because it feels like Ruby, and we love Ruby, but it's efficient and safer, so we love that. But it's up to you in the end. You can also use the two, and we have stories of people from the community that combines things like Ruby on Rails and Crystal. For critical endpoints that need to execute very fast, they use Crystal, and for the rest, they keep using the Ruby on Rails application. So this is also a possibility. All right, enough of Crystal as a language for humans and computers. Let's move on to other features that hopefully will get you excited about Crystal. So one thing that is lovely about Crystal is the concurrency, which is in the Go style, we call it. The idea here, so this little example is very simple. This just takes a list of sites, and it goes on each site, fetch the site, and count the number of lines. Why? Because it's an example. It's not something interesting, really. And then we sum up all the lines from all these sites. We want to do it concurrently because instead of waiting for and being blocked by waiting for the site to respond, we want to go and do this in parallel, concurrently, actually. Here we do it very simply by calling spawn for each of the sites. We go fetch the site, count the lines, and send the result to a channel. A channel is the way that fibers communicate between each other. A fiber is each line of execution. Then, for all of the sites, we receive from the channel the number and sum up this total number of lines and print it here. So as you can see, spawning different fibers to run concurrently is very simple, and you can communicate with channels. And this leads for a very smooth concurrent programming. We also have macros. Macros is compile time execution of code that allow you to mimic some of the dynamic behaviors of Ruby that we cannot have in Crystal because it's a compiled language. So let me give you an example. This example is from a Ruby site, actually. Now tweaking it a bit to be Crystal code. The idea is you create a number, a Roman number in Roman letters, and you can simply call a method using the Roman numerals, and it will be translated into the actual number. So in Ruby, this is done with a method missing method. Here, instead of being a method, is a macro. What's the difference? That this is resolved at compile time. So when you see here r.iv, instead, Crystal during compilation will call this method missing because there is no iv method in Roman, and call this Roman to int with the name of the method. In this case, Roman to int iv. And this will be translated then to 4. So this, with macros, we can get a lot of the dynamic stuff that Ruby has that you can have otherwise in a compiled language. Also, we have a dependency manager called shards. Libraries in Crystal are called shards. And the idea here is that you can easily add a file in your project, a YAML file saying what are the dependencies that you depend on. And then with shorts installed, you get all those dependencies into your code. And the last bit I want to show here is that you can do C bindings without much fuss. So here's the C code with a struct and a couple of functions, and you can link them here in Crystal with this special syntax for libs, or external libraries in C. And then you can use that from within Crystal with a couple of tricks, like getting the pointer of something, or initializing a new structure. So thanks to having this kind of bindings that allows you to very easily put libraries, there is a lot of libraries out there for different C libraries that you can find for Crystal. All right, I think I went a bit fast. The good news of that is that there is plenty of time to get your questions. There's more to Crystal you can find out on the Crystal homepage. I'm going to stay here for a while if you have any questions. Thank you.